Hi, I'm Sean Carpenter from Sonnet Software, and I'd like to welcome you as a Sonnet Lite user. You're probably viewing this video because you'd like a little more information on how you can use Sonnet Lite together with the AWR Microwave Office environment for high-frequency circuit design. I'm going to talk to you a little bit about that interface and show you an example of how you can use Sonnet Lite inside of the AWR Microwave Office environment. First of all, Sonnet plugs in. That's something you should be aware of. We use the AWR EM socket interface, which means that we've done the work in the background to seamlessly integrate our tool to the AWR Microwave Office environment. That's good for you because on one level you may be able to use the Sonnet EM analysis engine without ever learning anything about Sonnet. It all starts with an AWR EM project. The setup's very easy. When you install Sonnet Lite, it detects automatically the presence of the AWR Microwave Office environment and registers itself properly with the software. You'll see in the menus that the software is automatically made available, and we'll show you that in a few minutes. Now, you can also use the Sonnet Lite project editor for modifying the layouts in your AWR EM projects, or modifying metal types or other material properties as well. All of that information is available and can be changed if you prefer to work on your geometry or your materials in the Sonnet layout environment. It is also possible for you to take advantage of some unique Sonnet features such as components or auto-grounded internal ports, and those objects are wrapped up back in the AWR environment so that when simulation is initiated from Microwave Office to take advantage of the EM analysis engine, those features will stay in the simulation object. Now let's take a look at an example. In this simple tutorial example, I'm going to illustrate for you how you can use the Sonnet electromagnetic simulation tool within the AWR Microwave Office environment. It's actually very simple to use the two together. If you install Sonnet Lite after you already have the Microwave Office software, it turns out that Sonnet Lite will register itself with AWR, and simulation should be nearly automatic. But there's one thing that you need to know in order to set up your simulations. I'm going to illustrate that with the following example. This particular example has an EM project in AWR, and it's called an interdigital filter. There are 3 microstrip resonators, each of which is terminated by a via, which is perhaps more easily seen in the 3D view of this particular structure. When I simulate this structure, I want to use Sonnet Lite and the simulation engine in Sonnet Lite. I can do that without having to learn anything about Sonnet by actually setting the simulator, the EM simulator, to be used as the computing client manually from within AWR. The setting will be saved from now on for this particular project. I do this by highlighting the item for the electromagnetic structure or project in the AWR folder tree. I right-click, set the simulator as follows, and simply select Sonnet out of the list, and I'll now use, through AWR's EM socket, will automatically use Sonnet's EM simulation engine as a planar electromagnetic simulation client. Now let's check that out and see how it works. First, we'll want to see a response, and we'll press the Analyze button in Microwave Office. What you'll see are a series of messages that come from the Sonnet simulation engine back into the AWR environment, and the EM project editor, or rather the EM analysis engine from Sonnet, is actually being used for the simulation. The data has already come back. There's about 200 to 300 data points that have come back from the Sonnet simulation engine, and here you can see the simulation result for this particular filter. Now let's return back to our interdigital project example one more time. Suppose I would like to be able to modify this filter layout. I can actually do this in the Sonnet project editor if that's an environment where I'm more comfortable working. Let me show you how that works. Selecting our EM project over here on the AWR folder tree, if I right-click on that element, there's an option called Open in Native Editor, and Open in Native Editor will let me send this project out to the Sonnet project editor and open it up in the Sonnet project environment. Let's try that right now. I click on it, it's sent out, the AWR window minimizes, and up comes the Sonnet project editor with the filter loaded. You'll also notice that the reference planes have already been set as well in order to coincide exactly with where the reference planes are in the EM project in AWR. Now, Let's make some changes to this filter. I'm going to take and lengthen that middle resonator and make it a great deal longer. This will probably produce a nonsense result, but it will show us some of the things that can be done. When I save my changes here in the Sonnet project editor, Sonnet recognizes that there's simulation data left in this model, but it's now inconsistent with the geometry since the layout's been changed. I have the option to delete it, and of course I want to delete it because it's no longer consistent. Now, when I close out the project, it will load these changes back into AWR. So I close this. AWR Microwave Office will reappear back on the screen again, and through the socket interface, the layout will be pulled. If this is the first time you go to the Sonnet project editor, AWR will ask the question if you would like to use the native editor as your default editor. Since I may want to come back to the Sonnet editor again and again without answering this question, I'll select yes. If I select no, the AWR project editor will assume to be the drawing or layout editor that you'll continue to use, and any changes that were specific to the Sonnet model, that were Sonnet only features, will be lost. I'll use yes in this case. Now, notice how the layout changed and the middle resonator is in fact longer, just as we had made the change back in the Sonnet environment. Now, how does that change affect the response of the filter? Here's our original response. Let's take a look. Pressing the Simulate button once again, AWR reaches through the socket, sends the geometry back to the Sonnet simulator. The simulation is completed. 200, 300 data points come back through the socket again, and here you can see obviously the effect of changing that middle resonator has resulted in a seriously detuned filter. What this has illustrated is how easy it is for you to be able to take advantage of Sonnet Lite's project editor as well as electromagnetic analysis engines, all from within the AWR Microwave Office environment.